everybody. So in the last videos we went over the power rule, we went over the product rule and the quotient rule, addition rule, the constant rule. So we're going to use all this and prove our trigonometric derivatives. So we have 6 trigonometric functions. We're just going to write them as a review. So we have sine of x, cosine of x, tangent of x, cosecant of x, secant of x, which of these are the inverse on the right, and then cotangent of x. So we're going to start off easy, deriving the derivative of sine of x. And that one's easy to know. The derivative of sine of x is just cosine of x. And this will go in a loop. So if we derive cosine of x, we get negative sine of x. And then if we derive that, can choose to ignore that negative if you want. Just take it out, the derivative of negative sine of x. So we already know the derivative of sine of x, which would be cosine of x, but because we have that negative, it would be negative cosine of x. And then we see here, whenever we derive cosine, we get a sign change. So we have a negative now, we're going to get a positive sine of x, and then that loop will just repeat. So there we go, real quick thing, derivative of sine of x and cosine of x. But now to derive tan of x, cosecant of x, secant, and cotangent, we're going to be using the quotient rule for the most part. So we should know from pre-calc that tangent of x is the same thing as sine of x over cosine of x. So we're going to go prove these next 4 derivatives. In your calculus class, it might be helpful to memorize these. But if you're on a test, you're freaking out the night before, maybe during the test, best thing to do would be to know how to prove them. So I'm going to take the derivative of tangent of x. But I could have that memorized on the top of my head, but if not, I'm going to have to take the derivative of sine of x over cosine of x. So our quotient rule, just a reminder, we would define our numerator as u v prime minus, our numerator would be u prime v minus u v prime over v squared, in the form that our numerator is u, our denominator is v. So for all these, I'm just going to define each one. U equals sine of x, v equals cosine of x, u prime equals cosine of x, and then v prime would be negative sine of x. So using that, I'm going to plug it into our formula right there. So u prime I know is cosine x. I'm going to multiply that by cosine x, which is v, minus, we know u is sine x. I know v prime is negative sine x. That's multiplication over v squared, which would be cosine squared x. So looking at it, we should probably simplify this. So that would be equal to cosine squared x minus times the negative would be positive sine squared x over cosine squared x. So we should know that cosine squared x times sine squared x, again from pre-calc, would be 1. So our derivative would be 1 over cosine squared x. But we could do 1 better, and we should know that 1 over cosine, bringing it back up here, 1 over cosine would be secant, because these are the inverse. So we would take that, we'd say it's secant squared x. So now we know that the derivative of tangent x would be secant squared x. You could write it like this, or you can write it as secant x squared. But you cannot, just so we know, write it as secant x squared, because this would mean that the variable is not x, it's be x squared, which would be totally different. And we will go over that later. Not in this video, though. So we just went through tangent of x. So now we're going to go find the derivative of cosecant x. And we should know that that would be the same thing as taking the derivative as 1 over sine of x. So seeing that, u equals 1, we know that the derivative of a number, of a constant, would be 0. We know that v, the denominator, is sine of x, and that the derivative of sine of x we just learned would be cosine x. Just writing down the quotient rule so we can follow it. U prime v minus uv prime over v squared. Plugging everything in, we know u prime would be 0 times v, which would be sine x, eventually, which will just cancel out to 0, minus our u, which is 1. Our v prime is cosine x, over v squared, which is sine squared x. So seeing that this first term cancels out, I'm left with a negative cosine x over, I'm going to write it as sine x times 1 over sine x. I just broke this sine squared x up into 2 so it's easier to look at. So we know that would be equal to, so we know that sine over cosine is tangent, but here we have cosine over sine, so that would be negative cotangent x times cosecant x. And there you have it, the derivative, something that you should probably want to memorize, of secant x, derivative, that's next, the derivative of cosecant x would be negative cotangent x times cosecant x. So I want to make sure I did that right. Yep. Alright, so we got 2 more. We're going to go to the derivative of secant x now. And the derivative of secant x would be the same thing as taking the derivative of 1 over cosine x. So writing down the quotient rule, u prime v minus uv prime over v squared. Okay, so u is 1. Just like the last one we did, u prime would be 0. V equals cosine x. V prime, because cosine, the derivative of cosine will change sign, so we get negative sine x. I have everything I need to plug it in. So u prime would be 0 times v, which is cosine x, minus u is 1. And then I have times negative sine x over v squared, which would be cosine squared x. Here again we see 0 times anything cancels out. Negative times a negative would be a positive sine x over cosine squared x. And I'm going to rewrite that as sine x over cosine x times 1 over cosine x, which would be equal to tangent. Wait, what did I do wrong here? Are you good? Sorry about that. Yep. So times 1 over we'll go this way. Sine x over cosine x is tangent x times secant x. Most people like saying that the derivative of secant x is equal to secant x times tangent x. One of the only ones where you see the derivative, or see the same thing you derived in the final product. Alright, so we just did cosecant, secant. We're left with one more, which would be cotangent x. Derivative of cotangent x would be equal to cosine x over sine x, which, alright, so now we're going to say u prime, sorry, I'll write their quotient rule, u prime v minus uv prime over v squared. We know u is cosine x. Derivative of cosine x, or u prime, cosine switches sides, changes signs, so you get negative sine x. V is the denominator, which is sine x. V prime, which is cosine x. Alright, just fitting it into our equation again. Get negative sine x times sine x minus cosine x times cosine x over sine squared x. That would be equal to, so I see these two negatives here, I'll factor it out, and I can get a sine squared x plus cosine squared x over sine squared x. So that would be equal to, so we know sine squared x plus cosine squared x is 1. So I have a negative 1 on the numerator and a sine squared x in the denominator. We would know inverse of sine is cosecant. So I get negative cosecant squared x. Alright, so now we know that the derivative of cotangent x would be equal to negative cosecant squared x. So let's go back to the top. Let's copy this. So now we know that the derivative, just going to rewrite everything, the derivative of sine of x is equal to cosine x. We know that the derivative of cosine x equals negative sine of x. We know that the derivative of tangent x is equal to secant squared x, which is secant x squared, either one. Okay, 3 more. The derivative of cosecant x is negative cosecant x cotangent x. The derivative of secant x would be secant x times tangent x. So we see here that the derivative of cosecant is found here and the derivative of secant is found there with either the cotangent or the tangent function. So maybe that would help you recognize a little pattern that you could use. And then you have the derivative cotangent x. It's kind of similar to our tangent x, which would be negative cosecant squared x, which is the same as cosecant x in parentheses, squared. So there you have it. That's trig derivatives. On a test, you should definitely memorize that the sine of cosine, derivative of sine would be cosine, derivative of cosine would be changing the sign to negative and then sine. You could use those to prove the other 4 trigonometric functions. Thank you for tuning in.